Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about monoid and group. In our last class, we clearly discussed about algebraic structure and semi-group. This is a continuation part. Please watch that class and come back here. The link for the playlist is provided in the description below. Coming to today's class, so a monoid, a semi-group A comma and the binary operation here is multiplication is said to be monoid. So from this you need to understand, before you check for monoid, first you need to check for the set A comma and the binary operation that belongs to semi-group or not. In our last class we clearly discussed the conditions for semi-group. What are the two conditions it has to satisfy? It has to satisfy closure property and it has to satisfy associative property. Along with the two operations, monoid has to check for one more condition. What's that condition? If there exists an element E, this E we call it as identity element, such that A binary operator E equal to E binary operator A equal to A. You have to get the same element A. If this satisfies for all the elements in A, in set A, then we say it as monoid. With example, you are going to understand it better. Let's take the example one is all the natural numbers applied on multiplication. Natural numbers means it starts from 1, 2, 3, 4, so on up to infinite. These are all, we call it as natural numbers. So before you check for the identity element, first you need to check this set is an algebraic structure or not. It has to satisfy the closure property. You have to check semi-group or not. It has to satisfy associative property. Yes, it is satisfying closure property and associative property. You take any two elements from natural numbers, you multiply it, you are going to get the element that present in natural number. Yes, it is satisfying. It is satisfying associative property. You take any three elements, multiply in any way, you are going to get the same value. So it is satisfying the first two conditions. So you can say it is an algebraic, it is a semi-group. Now you need to identify for the identity element. In natural numbers, the identity element is 1. For multiplication, 1 is the identity element. You take any value, 1 multiplied by 2, you are going to get 2. 1 multiplied by 5, you are going to get 5. So that is what this condition says. A multiplied by E, E is identity element, or E multiplied by A, you are going to get A. So it is satisfying this condition. We call this as monoid. One more example. Example 2, A, set of all subsets of a set and union operator. In our last class, we clearly discussed that this is an algebraic structure and this is an semi-group. Yes, it is satisfying the associative property. But we need to check for identity element in order to say it as monoid. So here identity element is phi. Phi union anything, you are going to get the same. Phi union set A, set A. Phi union set B, set B. Phi union set AB, set AB. So it is satisfying the identity element and the property which says about monoid. So we call this as monoid. So hope you understand what monoid means. Now come to the next, okay, we are having one more example. All the natural numbers on plus. What's the binary operation? Plus. This is a semi-group. Yes, it is a semi-group. It is satisfying the closure property. It is satisfying associative property. What's the identity element for plus? 0 is the identity element for plus, but 0 is not present in our natural numbers. So the element 0 is not present in the natural numbers. So this set is not an monoid. You can say it as a semi-group, but you cannot say it as a monoid because we don't have the identity element. Now coming to the next condition, next statement, when you are going to say it as a group. You take a monoid A binary operator star multiplication is said to be a group. Means before you check for group condition, before that you have to check for monoid. Means you have to check for three properties. What is that? Closure property, associative property, identity element. After that, you have to check for one more condition. What's that condition? If each element is having an inverse. What's inverse means? A multiplied by A inverse. These are two elements from the set equal to A inverse multiplied by A equal to identity element. If you get identity element, if this satisfies for all A values, then we say it as a group. Let's check the examples. Example, R plus star. What's this? Set of all non-zero positive real numbers. You take the real numbers, non-zero, zero is not involved in it, means from 1 to all the real numbers. If you apply the multiplication operator, yes, it is following the closure property, it is following the associative property, it is having the identity element. What's the identity element here? 1 is the identity element for multiplication. In the above monoid example, we already know this. 1 is the identity element. But we need to check for inverse of the elements. Is the inverse of elements possible for all the numbers? Yes. If you take any number multiplied by, what's the inverse? 1 by A is the inverse. That is going to give you 1. 1 is the identity element. A multiplied by 1 by A equal to 1. You take any number, 5. 5 multiplied by 1 by 5 equal to 1. For any number, you are having the inverse, which is going to give you the identity element. So we say it as a group. So group has to satisfy 4 properties. It has to satisfy first closure property, associative property, identity element should be there, and inverse should be satisfied. Hope you understand the definitions of monoid and group. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.